Today, welcome everybody. In today's session, we'll be talking about data quality and how do we look at data quality being implemented by certain other organizations who have been using Great Expectations. That is one of the tools that actually was a blip on the ThoughtWorks radar for quite some time. And that is when I started, like looking into that, and that is when I started seeing that there are quite a few organizations who are using it pretty effectively, actually. That's what we are going to talk about today. And yeah, before we go there, I would not hit it on present. If it's okay, if you can read it, I think it's just going to be fine. I'll just work through different tabs on the basis of that. What do we really mean? Why do we need data quality? Now, one of the blogs that we had written early on, this was like in the September of 2021, I believe. At that time, we were looking at AI, like minus all the hype that is there today. Of course, it was, like leading up to where we are today, but we are looking up to that. And then we realized that uh, for us to build any kind of model, or for us to even get closer to build any kind of model, we need a lot of work that needs to be done in the background. And this work takes almost 80% of the effort as compared to, like finally getting to the model and building the model and then, like tuning the model. So the cleansing, the labeling, the augmentation, aggregation, all of this is data. And essentially what is happening today is that a lot of organizations, they are just saying that, hey, we want to get onto AI, we want to look at whatever we can do with AI, but nobody's talking about data as much, because without that data, like you are looking at building a penthouse without building the floors underneath that. And yes, I need the penthouse, but where are the floors? So I think that is where data quality is a huge requirement, and it is paramount that we get that right. And that is something that Great Expectations as a tool tries to solve. So what is data quality? Now, data quality is the degree to which the data contains or is free of errors. So that is what we talk about data quality. And then if there are errors in data, then everything goes for a toss, right from your ingestion to your data products and so on and so forth. Uh, Historically, what has been observed is that there are three major reasons because of which we have errors in data. One, either the input itself is incorrect. So, like when we were entering data, somebody was typing in data, when we were ingesting data, that input by itself was incorrect, and hence we have a data error. Second is the interpretation of the data is incorrect. That means that uh, we were thinking that the data is of a certain type, but it was something else. So say for example, we see a mean calculated, and we say that, oh yeah, this mean is calculated on all time data, whereas that was not the case. It was actually calculated on the last 2 months data. So that is the interpretation where we think that data is something, but it is something else. And then the third part is that the understanding of data itself is outdated. That means that uh, we had certain amount of data in the system. Say for example, age of people. This is like historic data. This was 5 years ago. Now the age of all the people, that has changed. Or addresses of people, the addresses of those people have changed. So the data by itself is outdated. So most of the data errors, they can be attributed to one of these three categories. And hence, like the errors get introduced into data. Now, for data quality, these are the 6 parameters that need to be looked into eventually, whether it is complete, whether it is accurate, whether it is consistent, the validity, uniqueness, and the timelines of the data. And together, these attributes, they categorize whether, like the data is of the right quality or not, and whether it is really the kind of data that we want or not. Uh, Recently, and this was end of 2022, Great Expectations, they like joined hands with one of the survey companies, and they ran a survey across multiple enterprises. And these are some of the top problems that the enterprises came back with. So the top symptoms of poor quality data, as you would observe, many of them. So what are the symptoms? So many enterprises, they are experiencing broken data applications. There are broken dashboards. People are in disagreement about organization metrics. And I believe that this is something that we see a lot. Somebody, like we see a report, there is another person seeing a report, and then they say, oh, like this does not look right. So that is all inherently because of bad data which is getting into the system. Like, it doesn't matter whether you have a data lake, it doesn't matter whether you can put Power BI on top of that. But if the data which is actually powering all of this is incorrect, then there is like an inconsistency no matter what. Many data scientists and data engineers, they are spending too much time just preparing data because there have been historically problems with data. Like data is not clean, it needs to be clean. So preparation of data by itself is taking a lot of time. And then the business decisions are being made on this error-prone data, as a result of which the business decisions are questionable by themselves, and so on and so forth. So anyway, like there is a link to the report over here for those of you who are interested. Like it's like a 20-page report. You can go ahead and read that. I just brought out some of the interesting portions out of that. But essentially, the bottom line is that there are a lot of data inconsistencies. There are problems in data, so on and so forth. Now, I was interested in looking at like what is the tooling that most of the organizations are using and how closely they relate to what we do as an organization. So interestingly, a lot of tooling is just in our wheelhouse. So if you look at data warehouses, like we are on Snowflake, we are using BigQuery, we are using like SQL Server in some of our clients, so on and so forth. Cloud storage, most of the enterprises, they are storing their data on the cloud storages. They are visualizing their data using like some of the visualization tools that we see here. They are using scheduling and orchestrating frameworks like Airflow, Oozie, etc. And a lot of use of Spark. Like, so this is again end of 2022, somewhere around that. But a lot of use of Spark still going on. Git, obviously, like, but DBT as well. I know, Ram, you keep talking about DBT, but a lot of DBT being used. Then I looked at what are the languages that are getting used across enterprises, and I was surprised to see, like Scala still enjoys a good, like majority in terms of a lot of data work getting done. So again, the hunch is that a lot of this is Spark work, and a lot of code is being written in Scala for Spark. But again, as you see, like SQL, no surprise there. Like a lot of database data. So SQL, Python getting used a lot, Java, Scala, R, and then there are others. But again, just to give you a context, like this is just the data quality report, but data problems are huge. And then I started thinking that across our engagements and how many projects we have encountered the same thing. I know for sure that like one of our biggest clients in IoT space, they kept asking me that how do we ensure that after every step our data is accurate? And at that time, we did not have a good way of doing that. But this is what Great Expectations solves very well. So let us talk about Great Expectations, and then we'll go from there. So what is Great Expectations? Great Expectations, again, like it's a tool. It's an open source tool. Now they have built a cloud platform around that, and they are offering that as a commercial solution, as well as most of the open source companies are. But essentially, what it promises is that it is a tool for data science and data engineering teams to make sure that all your data assets, you can pump them through Great Expectations and get results like quality of the data. You get metrics on that. You get documentation on the data. You get data quality reports. And then you can put in your logging and alerting so that whenever there is a discrepancy that you see in the data, you can actually trigger it off and take some action on that. So that is the promise of Great Expectations. I just pause here. Like, so far, any questions about the survey or anything that I've been talking about? Ram, you're on mute.
Oh, sorry. Actually, slide 7, Vikas, I'm curious, what is the historic variation? Like, is Scala going up or going down, or Python? Maybe they did not publish.
Yeah, so there is not history, like it was in a snapshot of time. So they interviewed, like they have the details over there, but I believe they interviewed 100+ enterprises who have a lot of data, and these are in the enterprise grade, so they are like over $500 million companies. And Scala, frankly, I was surprised to find it there, but then I correlated it back to some of the like the tooling getting used, and again, I believe a lot of that is coming from Spark. I could be wrong, but that is what it feels like because Airflow, Oozie, etc. Like they are more Python centric as compared to like Spark. So That is the gut feel, but yeah, I don't have a answer to
Yeah,
that, like of the history.
yeah, that's fine. So, I was thinking maybe going forward, we may have to invest and skill up. And it's fairly easy to skill up on
Mm.
Python because I'm seeing a lot of tools and platforms and, like Python is becoming mainstream. I remember UKG, they were asking, are you Python first company, right? And we were
Yeah,
pushing that we should do Java and Scala. I think Python is coming more and more into data as well. And obviously this slide proves that.
it is.
Um,
It
yeah.
is. And yeah, I think Python is just getting used everywhere. Um, uh, yeah, like for myself, I'm still a fan of more compiled languages than dynamic. So it just feels that way. But yeah, like Python, I think it's easy to get onto. Like it has got so many libraries, even for like building some of the great expectation work. It was just easy to like pump in a library there, get metrics, get like visualization, so on and so forth. So I think it is pretty easy. Uh, so yeah, like I think it is a call that we have to take, Ram, that is this going to be a level one language for us? Because so far we have been Java-centric, Scala-centric organization as such. But I know that a lot of work that you guys have been doing on the Google Vertex AI, that is a lot on Python as well, right? So in any case, I think it just seems like getting there.
Yeah, yeah. The reason is I think in Python world also there are new packages like Pydantic,
Hmm.
which is helping enforce type safety.
Hmm.
Um, so that
Hmm.
is actually a very, I think, Pydantic, somebody showed some statistic. I'm going off topic, but long story short, there are libraries that kind of bring Python very close to a regular compiled programming language like Java. And I see
Yeah.
patterns, like dependency injections, all these being, I mean, maybe that's another knowledge, the modern Python, right?
Yeah, and I think that is a requirement as well. I think yeah. So see, just like Java had, sorry, JavaScript had TypeScript, and the reason was because we wanted some kind of typing over there. So I think similarly in Python, if there is something that ensures that, because sometimes when I was trying to write code for Great Expectations, like sometimes I was just not getting the right data type, and then I realized, okay, I had to go and check the function that like what is the data type that it is returning. So something like Pydantic, or as you said, might be helpful. But yeah, nevertheless, I think Python is needs attention. So I think from us as well. And I don't know how much Nashtec in Vietnam does that, but yeah, probably we need to do better here. So anyway, coming back to Great Expectations. So again, like a tool, well, it is a Python first tool. So a lot of expectations, they are written in Python. So that is what the expectation is as well, that, like if you can write it in Python, that'll be good. Now, so when to test? Now, according to Great Expectations, you should test at any opportunity that you get. So the idea is that test before ingestion of data, test after transformation of the data, because once you start doing that and do that at every step, wherever we are ingesting data, wherever we are transforming data, like have that Great Expectation check going on there, so that we know that, okay, after this checkpoint, this is the kind of data that we got, and we are validating that data. So the benefits, of course, are that we are preventing incorrect data from entering into data products. So as we are talking about data meshes now, so the data entering into data products need to be correct data, and that is what needs to be ensured. Uh, it allows in making the implicit knowledge explicit. So sometimes as a domain expert, we may know that, oh yeah, like this particular data cannot be beyond 0.5 and 0.9. But this is something no from a domain perspective. But once we explicitly write a test around that, then the implicit knowledge becomes explicit that yes, like this domain entity or this column cannot have a certain value, and like it has to be in this range. And then it allows in developing rich documentation of data. So the idea is that we are not uh, we are not using Great Expectations to run a pipeline, but it is going to be run as a part of the pipeline. So the pipeline would be still be running with the likes of Airflows and like Uzis or however we are doing it. And then this is just going to be one step in that, okay, yeah, like I have ingested my data. Let me just call out the GX suite, get the data validated before I start transforming it, and so on and so forth. The key feature, as you would expect, like in any other unit test, is that there is an expectation. So the expectation is what you'll define, that this is what you expect your data to be within this range, or not null, or it should always be 0, or any of those expectations that you can define. Now, the good thing is that either you can manually mention these expectations if you already know the domain, or you can just set GX, open over the data set that you have, and it'll collate the expectations from there. So it'll read the data and it'll say that, okay, yeah, like given that you have given me this data set, for all the columns that I've observed, or for all the, like the values that I've observed, I know that, say, the density of this material should be between 1 and 3. I'm just throwing out an example, but then that is how it can infer as well. So either we can manually set expectations, or we can profile it. And then what happens is that you get a data validation result. So once you pass the data through that, and I'll go through the, the steps, but once we pass data through that, then we get a data validation result, which is in a human readable format. So it produces an HTML. It does produce the metrics as well. So you can say that, yeah, this is something that I need to look at, but I also want the metrics so that I can build a trend or a history around them. So it pumps out all the metrics so that you can, still build your histograms on top of that. Julie, you had your hand up.
Yeah, but I was just thinking about my question, didn't really make any sense. So please continue. I'll catch up. Yeah.
Okay, we'll come back. Okay, so let us talk about the key concepts of GX, Great Expectations. So the key concepts are, it has got a data context. Now, for those of us who have been, working with various kind of contexts, so we have the servlet context, we have, context in Spark, we have the EJB context. So context is nothing but, it is the domain, or it is that logical entity which allows you to define everything. How do you configure your paths? Where do you want the metrics to be pumped out? How do you do your setup? And what are the different validations, expectations, etc., that you'll be defining, and that so on and so forth. So you start with the context by defining that context. Then you have data sources, that this is from where I'm going to be reading the data, and this is where this is the kind of data that I'll be reading. So data could be of various kinds. It could be structured, unstructured, file types, like BigQuery data, so on and so forth. Then you define your expectations, that these are the expectations that I have on data. Now, either, as we talked earlier, you can manually write the expectations, or you can build the expectations through profiling and save them. Then you have a checkpoint where it says that, okay, now run these expectations. And then you get the results. On the basis of the results, then you can go either way, and you can say that, oh, yeah, like do this or do that. So that is generally how the flow happens. Pretty simplistic flow if you look at it. It has got 4 steps to it. And so if you look here, now this is the data context. And the data context is the entry point for configuring interactions with the Great Expectations. So as we discussed, but it has the setup, it has got the connecting to data, it has got creating expectations, and then validating expectations, validating the data against the expectations. So this pretty much sums up the flow of how GX works. And then now gradually we'll start going through it step by step. But I'll just pause here and see if there are any questions.
I'm curious, during the validate data step, probably it's a configuration, setup thing, but does it validate a set of data, or is it going to check against every data element?
Yeah, it checks against every data element, Ram. So anything and everything that you're passing will check everything. However, it'll give you, say, for example, if there are failures, it'll give you a sample set of the failures. So I'll show you as we run through the example as well. So I've got a few Jupyter notebooks on this that I created for running through some of the data sets that were available. Yeah, validate data can be, you can just say that validate it against the entire data set, and it'll just do that for entire data set, because it wants to make sure, the idea is to make sure that whatever data we are promoting through our pipeline, that is correct. So it validates against each and every item of the. You can specify configurations to say that, like, exclude this data. I don't care if this data is incorrect for the sake of, like, moving fast, but it, like, moves pretty fast. I tested it against, like, file sizes of 200 megabytes and then so on, like 500 megabytes, so on. And it was instantaneous, like it is millisecond responses. So it is doing it pretty okay. But again, I'm running it on the local file system. So yeah, like haven't tested it in production yet, but very interesting, whatever the results that I found. So let us.
Sorry,
yeah.
just quick, because in this, is this also a sort of a set of cycle steps? So checkpoints, can you set up multiple checkpoints? I'm just thinking of a previous project that I've been on where we had that, we broke it up into about 3 or 4 of them, and you do a checkpoint, and then it's kind of start again. You start with that point of data, so you could break it up into phases and root cause analysis, that kind of thing.
Yeah. So what I have understood so far is that, so what I was thinking is that, like, if there are, say, 4 portions in the pipeline where I'd want to do a check whether my data is valid or not. So that is not called a checkpoint. A checkpoint is, so for running a validation, that is what they have. So the checkpoint is checking at that point what is the data validity. But it is not something that I can go back to. I can use the same checkpoint because the data of that checkpoint gets stored. So I can see that, okay, data at checkpoint A was certain data and data at checkpoint B is a certain data. I can do that, and if I do want to do a comparison between the two, we can do that. But it is not that we can just go back to a checkpoint and then, like, rerun that checkpoint, if that is where you're coming from.
Okay.
At least, yeah, like I did not see it that way.
Yeah. Okay, that makes sense.
So let us see this one. Like, so this one is a very straightforward example. Yeah.
Sorry, because if you go back to the slide,
yeah.
So I thought context means it's kind of set up. The actual execution happens after the context is set up, right?
Yeah, but everything is a part of the context. So once we set up the context, which has, so the context would have the data sources, the context. So consider context to be, and like that is where I was drawing the comparison with the likes of EJB context, or like say for example, if we are using Akka, then in Akka we have got something called the actor system, right? So the actor system is pretty much the context that we are building everything under the purview of this context. Now this context knows about the data sources that I'm going to be using. This context knows about which file systems I'm going after. This context knows about what expectations I'm going to be running. So the context, consider that to be the root of the system, which knows everything about like the GX validation that we are running. So that is the context. So that is how they call it here as the data context. And I think it is very similar to how we had the servlet context, or like the EJB context, and so on and so forth, and maybe the actor system in Akka.
I think actor system makes it easy to understand. Like it's
yeah. You just set up the root, and then after that, like everything is a part of that. So that now, so the context is aware. Now, if I want to know that, okay, what are my validation suites, I can go to the context and say context.get validation suites, and I'll get a list of all the validation suites. I can go back to the so I can keep adding expectations to the context. Say, for example, I added 2 expectations that one, this column should not be null, and another column should be having a range between A and B. And then I could add another expectation afterwards, after doing certain validation, and say, oh, now I've got another expectation, then do this. So I could go back to the context and get a list of all the expectations. So it is pretty much like a superset of all the information that I need.
So you would do something like context dot validate data, and it will create a checkpoint.
That is correct. That is correct. So yeah, if you now look at this one Jupyter notebook, and then I'll like open others. So what we are doing here is that, of course, like importing grade expectations as GX, so that we are not writing a lot of grade expectations again and again. Then here we build the context. So this one is building the context. Okay, let's build the context. Now, this one is a simple example. We are just using one file over here. But what we are saying is that, okay, in this validator, so we are not explicitly creating a data source, but we are saying that, okay, in the context, using the source is going to be my, like Panda's default, which is going to be a Panda system, and read this CSV file. So we're just passing on one CSV file to it. And this becomes our data source that we are passing on to the validator. On the validator itself, we are specifying certain expectations that, okay, this is what we expect and this is what we expect. So we say that we are expecting this particular column. So by the way, this let me open this as well. So this is a CSV file of yellow cab trips in New York on a certain date, and this has got like a lot of details, like who's the vendor, what is the pickup time, trip distance, so on and so forth. So like a lot of information here. But we are just like interested in a couple of columns just for the sake of this example. And I just said that, okay, let the pickup time not be null. Pickup date time cannot be null. So that is one validation that we want to run. And we want to make sure that the number of passengers in the cab, they are not more than 5, because like there is the driver and the cab should not have more than 5 passengers. So these are the two expectations that we ran it with. And then, Ram, as you said, a checkpoint is just saying that, okay, let us create a simple checkpoint in which this is the validator that I'm going to be using. This is the data context, which is the context. This is from where I'll be getting all the, like the source information. And then we just do a run on that. So checkpoint.run is just going to do a run, which is going to be calculating all the metrics, and then it will be dumping out the result. And again, we can decide how do we want the result to be, where do we want it to be dumped out. But right now, it will just write it into a temporary location on the file system, and we can see it from there. So if we run this code, you'll see that it'll like do all the things that it needs to, and then it opens a. Okay, let me see if I can bring it to this browser, and then it dumps the data into the file system as an HTML, and this is how you can see it. So if I share this tab, now you'll see that this particular data ran on that CSV file that we were talking about, and it ran those two validations. So it said that, okay, yeah, like none of the pickup date time is null, which is what we expected it to be. However, it said that there are 252 out of 10,000 rows, 252 which have got a passenger count of 6 instead of what you were expecting it to be between 1 and 5. So then after this, what you can do is that you can write an action to say what do you want to do with that. Now, whenever you see that there is a discrepancy in the data, or you found out that data is not correct, then you can say that, okay, Slack a message, or raise a pager duty, or like send out an email, or like do whatever. So those are the actions that we can specify for it to start taking action, so that we can make sure that either the pipeline stops, or we correct that data and then run the next part of the pipeline, and so on and so forth. So I just pause here. Questions, thoughts?
Because a lot of this seems to be data like ETL process, extract, transform. Looks like it's happening more of a filter and the checks.
It is just the checks. So it does not do extract, it does not do transform, it does not do the load. It is just doing the checks pretty much. Well, it does a load in the fact that, yeah, you're telling the data source to it, but it is not meant for doing any of the ETL. It is just meant for checking data. That's it.
Right. So what if how is it different doing these checks in simple Spark itself? Using data context.
We can. Yeah. So that is a question that I had as well, and I started thinking about, like I could have done this easily on my own, right? We could have just written a check, and I could have written an assert over there, and I can write asserts in my programming language, right? So I can just say that, like assert that this. But see, the thing is that ultimately again, yeah, they are not trying to solve something which cannot be solved by us writing code, but it is a library that exists with a lot of bells and whistles, otherwise which we'll have to code for, right? So the thing is that we have this tool in our arsenal now that yes, whenever we are doing a pipeline check, we can just, like put it onto Great Expectations. It'll just do that check for us. And then we get all the goodies along with that. Every checkpoint throws out data that you can, like throw out to whatever location. You can build your metrics on top of that. You can create your histogram on top of that as to which portions of the checkpoints did you actually, like fail on, and so on and so forth. So I agree. See, like ultimately, we could also say that, hey, we could have written Spark, right? Why do we need to use Spark? So it is just a library, but it is a useful library. That's what I thought. That allows you to do, which is just focus on data quality checking, and does that pretty well actually.
Right, because the only question that nowadays businesses think about is that why to adopt a new technology if something that can be done with an existing technology, because new technologies need a lot of new investments, and finding right people with that knowledge is pretty hard.
Yeah, but see, like if you're already using any kind of a pipeline, so I'll just jump ahead and I'll come back to like the rest of the what I had to talk about. But and then I started scouting, like how are people actually using that? So if you look at any of these pipelines, I don't know how readable this is, but at every step, you're like moving from one environment to another, doing any kind of data transformation. So this is how people are actually using Great Expectations. So they put it as a pipe of the pipeline, and like just do it from there. So similarly on Spark, like so this is something that I wanted to talk about as the last one, but since we are talking about it, as a part of Spark, you see, like people are using EMRs and Sparks and whatnot, but for data validation, you can actually just do data validation with Great Expectations. So we are using Spark for what it does best, right? And then we are using another tool along with that for doing what it does best, and then building our story with that. So yeah, like yes, we could write code for it ourselves. That is the first thing that came to my mind when I started using this and I started evaluating this. That yeah, like what's the big deal? I could have just done it on my own. But once you start looking at the other features and other like things that it brings in, then it starts becoming obvious that yes, it is going to take work for us to do that. So instead of doing that work, like there is something that exists. It is in the open source. We can just go ahead and use that. So that is where it becomes more interesting.
Another big advantage could be, separating the actual ETL code from validation code, right? Like already pipelines are pretty complex. You don't want to like embed all the validation and then get confused. And also, you can work with the business to define what are the requirements of data quality and then implement them and show them how your whole system is performing on the data quality front. I think that's another big advantage.
Yeah. So if you notice, like at all of these portions, yes, you're not doing any of your ETL here. You are just injecting those checks here at the right point so that you can get an alert if it is failing. And for one of our clients, this is exactly what we needed. Like when they were asking that, okay, like how do you tell me that at every point my data is okay? And like what is the quality of my data? We did not have a good answer at that time until we discovered this one. So okay, I'll just move ahead. So let us talk about connecting with data. Now, getting into some more details now, and probably it will become a little more interesting or a little less interesting, we'll see. But when you connect to a data source, essentially what happens is that we are telling that, okay, this is the batch of data that we'll be connecting to. So if you look at this particular diagram, so connecting to data, ultimately, when we connect to data, then we pass on the data to the validator for the validator to validate the data. So that is all that happens. However, inside the data source, when we are connecting to data, what Great Expectations is doing is that it is churning up something that is called the execution engine. Now, this engine is responsible for processing the data and computing the metrics. So just think about, Himanshu, to your point, when it is calculating all the metrics. So all of this is something that we'll have to write. That 10,000 rows across one file, and like 100,000 rows across like 5 files, and this is the percentage, and this is that. So all of that work is getting done as a part of this execution engine. And then it is throwing out that data wherever we want it to. So we wanted to run it into a SQL table. We want to dump it into the file system. We want to put it on S3 or whatever. All of that is getting done, and we can configure that. And then, like the batch that is prepared from the data set that it is ingesting, you can pass it on to the validator in order to validate that. So essentially, the batch that you are accepting for validation, you can run your metrics on that as well. And then you can pass it on to the validator and run metrics on that as well. So it allows you to, the execution engine, like works in that way that you can know that, oh, I loaded 100,000 rows. Out of these 100,000 rows, like this is how the scatter diagram look like. So we can do all that kind of stuff and then pass it on for validation as well. So execution engine gives you that capability.
And because
yeah,
if you go back, see, let's say the source system is BigQuery or Redshift or some massive data store.
Yeah.
I'm hoping the execution engine in that case, it connects and it hopefully it sends out an SQL, executes on the target, and brings only the results back, versus the other way is get all the data and try to process it in a Python code.
No, you are absolutely right, Ram. And that is what, so if you notice this first component here, that is what the batch request is. So in the batch request, you tell what is the kind of data you want to get. So that batch request is filtering out the data on the basis of what you need. If it is a SQL query, then it will filter it on the basis of the results of the SQL query. In my case, what I did was that since I'm working on the file system, I just gave it the CSV file system. And I'll come to the next example in which I'll show that. But this is exactly what the batch request is for, because you do not want to boil the ocean here. Like it is never going to work. So you want to make sure that you get the data that you are interested in. And that is what is the work of the batch request. So that creates the data set which you want to further connect to and take it further. Right? So as you see here, like of course it can connect to file system, it can connect to Spark, Google Cloud, Azure Blob Storage, AWS S3 database, in-memory SQL, and these are just some of the examples. Possibly there are more because there is an entire community behind that who's like pumping in more integrations. But these are the ones which are readily available. So for us, as a cloud native provider, all the clouds that we work with, those are available. Like anything that we want to do, all of that is available. So pretty good from that perspective. And again, like it's not again a single file. You can just specify a bunch of files to be imported. It is going to import all those files and run the validations on top of that. Quickly coming on to expectations now. So as we talked about, so expectations, again, they can come from your domain knowledge. If you know what the expectations should be, they can come from profiling and introspection. Once you ask great expectations to profile it, if you do not know do not have domain knowledge, give it the gold set and say that, oh yeah, like this is what you have. Just tell me what you find out. It is going to tell you, like whatever it finds out. I'll show you an example for that as well. And then you can write your custom scripts and so on. So expectations by default, GX provides, I believe, was it 30 or 100? Like those come bundled in already. The community has already contributed 300 plus more. So as soon as the community builds a new integration, say for example with GCS, then they write expectations for that as well. That these are the common expectations that you would use on a BigQuery, and those are available in the like expectation space. So some of the common expectations that exist are, and this is a very small snapshot. Say, for example, some of the column needs to be between this and this. The column needs to exist. The column should have unique values between this and this, so on and so forth. So the column Z-score value should be less than this. So these are some of the common ones that get used a lot. So these come bundled along with great expectations. But then you can, use the community ones, and you can write your own ones as well. So this is where this custom scripts are available that you could, like write in your own expectations. And then the last part is the validation part. So you have the data connected, you have the data source built, you have, of course, you have the context from which you started, you have the data source built, you have the expectations defined. And then you come to the validation part where again, as you notice, what happens is that you trigger the checkpoint. So checkpoint is what runs. So you create the validation, you create a checkpoint in which you put the validation that, okay, this is the validator that I'm working with. You run the checkpoint. Once the checkpoint is triggered, then in that case, it does all the fancy things that are required in the background, get the data from the data source, apply the validator on top of that, and pump out the validation results to wherever it needs to be, and then run the actions on that. So again, the actions, some of them could be updating the Datadogs, sending out emails, Slack messages, PagerDuty, whatever you want it to be. But this is what actually triggers the final go on that.
Vikas, on the previous slide where you said the introspections, what exactly? 70, slide 70.
70, this one?
Yeah, introspection. What exactly it will do?
Yeah, introspection is, so just like we have, say, for example, in Scala, we have got something called type inference, where the system itself or the compiler infers the data type of a variable. So in this introspection, what we are saying is that that we do not know what are the upper bounds and lower bounds for a data because I'm new to the domain. Say, for example, if you get insurance data, like I'm new to the domain, but the insurance company tells me that this is a gold data set. This is the best data that you can have. So I'll run the profiler on top of that data, and I'll ask grade expectations to infer or introspect that data to tell me what are going to be the upper bounds, lower bounds, which values are never null, which values are zero, like what is the range of values available, so on and so forth. So that is the profiling part of it.
Oh, yeah, got it. And generally, I was just thinking, because I end up doing something similar exercise for our Loblaw friends when they were getting wrong items under the new arrival menu, and it was a data issue. The question came to me that, hey, I will prefer to go back to the source of the data and fix it. So is any way we can find out source and give the feedback? It does connect to some of the tools.
Yeah, so you would not be able to find out the source just by running a checkpoint at any point. See, what grade expectations is telling us is that, like whenever you are, say, so from the source as well, when we are injecting data from the source, right? So when we start injecting data, at that time, we can run a data validation on that data set to say whether this data is valid or not. So even before ingesting it into the data pipeline, we can make sure that the data is correct. If the data is not correct, then we know that like we need to correct the data. Or at any point during our pipeline. So like if you notice, data ingestion, we can do a validation there. Data cleaning, after data cleaning, we can do a validation there. After feature engineering, we can do a validation there. After model output, we can do a validation there. So depending upon where we think we need the validation, that is what GX says, that like you should put in the validation there so that you are sure about the data as it is progressing through the system. So it can be put at the ingestion point itself. And in that case, probably we would have known that, whatever data is getting ingested into the pipeline, which is finally leading up, showing up wrong menu items, like it could have been corrected there itself. But at any point, we can run this ideally, and we can get the results on that. So it's not going to tell the source per se, because then it does not know. But if we run it at the right points, then of course we can know at which point it went bad. If it did.
On this note, because just one question: does the data needs to be persisted into some kind of a DB before we do the validation, or at each point we can just keep the data in memory and do the validation?
Yeah. So you need to specify the data source. Mm-hmm. So your data source, as Ram asked, like on the basis of the batch request, you will tell where do I pick up data from. So it could be coming from a SQL file, it could be coming from BigQuery or whatever. So once I have the data source, then I just run it, then it does the computation in memory and churns out the results. But if you want it to write that data as well, it'll write that data as well. So all of that functionality is built in that, like you want to dump it out, it can dump it out. But
right, because I think this might not work with in-memory data.
It works with in-memory data. That is, it works with in-memory data. So it works with in-memory databases. I think I did cover that earlier. So
something like Redux, it will work with Redux also.
Yeah, I don't know. Yeah, since it works with the in-memory databases, probably it works with the Reacts and Redis of the world as well. Again, not given a try, but yeah, like all of those blocks that are called out there, they have examples and like tutorials for all of them. So
no,
is,
by in-memory data, I mean not in-memory DB, but like kind of data which is kind of in JVM or in systems memory.
well, if you can see, ultimately, it doesn't care where the data is. If you can build a data connect to that and get that data somehow, it'll work on that. So it does not care, like where the data is coming from. So if you think that the data which exists in my JVM, like I want to dump out the stack or a heap and like get the data from there and pump it into this, yeah, it'll just take it. Like it just needs data. So
understood.
Okay, and quickly, what maybe I'll show you this, and then so again, just like we showed in the last example, in this one again, we are setting up the context, we are connecting the data. Now, in this case, what we are doing here, Ram, as you noticed, so we are giving it a batch. So we don't want everything and anything under this directory. We just want the CSV file. So there could be like ton of other files that exist, but what we are saying is that we just want the CSV files, and then we can, like in the regular expression, we could just specify maybe the CSV file starting with T. So that is pretty analogous to what you were asking, that if I have got a huge data set and I need to filter out, so this is filtering out. So we are creating a batch in which we say that, okay, just get the relevant CSV files, which is under this, like grade expectations, knowledge data. Just get the CSV files from there. That is going to be your data set. And then create the validator on top of that and like run the validation. So rest of the things are the same, but then it'll run on that filtered set of data that we have in the file system. Similarly, I had another probably example that I can show you. So similarly, say for example, in this one, what we are doing is that, so this is like, so we build the context, we get the data. This is where I was just trying to see like what is the header of the data here. But here, what I did was that I did not give it any validation expectation in terms of, so I let it profile data. So I told it that, okay, exclude these columns because I'm not interested in all of these columns. I'm just interested in a subset of 4 columns. So on the basis of that, it gave me this. So I asked it to profile an expectation, and on the basis of that, it gave me all the ranges that, okay, if you're looking at passenger count, maybe we'll just try to. So if you're looking at passenger count, then in that case, the minimum value that I found was this, and the maximum value that I found was this. So things like that, it infers, and on the basis of that, it builds its own like understanding of the data, and then we can. So column max. So here it says that, like the minimum value that I found was this, the maximum value that I found was this across various batches of data that it is sampling. And then on the basis of that, it'll say that, okay, it is between 0 and 6. So here, this is how it can infer data. And then on the basis of inferring data, then it forms its own validation suite that, okay, now whatever other data you pump in, I'll be able to do it on the basis of that. You can save the expectation suite that you create out of your gold data set, so that you can run it for any other data set that is coming. So that is also possible. And then of course you can, like plot the metrics, and you can just see, like what are they looking like, so on and so forth, so that you can save this expectation suite, and then you can just keep reusing it wherever else you want to. You're on mute, Ram.
Sorry. Do you think if there are multiple data sources and ETL pipelines, which happens all the time in production,
Yeah.
Like, is it going to be a separate pieces of great expectations code that runs in different intervals, or is it going to be one large validation, one context, and then you have like, multiple, I'm just trying to.
Yeah, I think I get your example. Yeah, my guess, Ram, is that it is going to be, I would do it separately, because like, say for example, like in some of our clients, when we are reading from Vertica as well, and we are reading from Oracle as well, and when we are reading from another system as well. So the first thing that we want to check is that once we do the read, is my data accurate after this read from this data source? So probably we'll put a validation check over there to just validate that the data is correct for all three of them. And then whenever we are taking it further and doing the transformation or aggregating that data, after that, we'll put another validation check to make sure that whatever we were doing after that, it is valid as well. So the number of rows that we were getting after combining them, we expect it to be this, then we put a validation there, and then so on and so forth. So GX says that you can just put it anywhere and everywhere that you want to, but we want to make sure, because this is going to incur, memory, this is going to incur cost, time. So we want to make sure that we want to put it at the right places. But Great Expectations by itself says that, just go ahead and put it wherever you think that you need to check on your data. And yeah,
that makes sense. I mean, it's probably like, in Airflow, you create a DAG, let's say, one branch. After that, you run GX.
Yeah.
If it's valid, then proceed to the next branch, so on and so forth.
Correct. And I believe I had put in an Airflow example as well, just to show that. Yeah, so this is an Airflow pipeline. So this one, yes, so we validate the data source here, then we load them into the DB, then we are doing a validation, then we run the transformation into DB, we are putting a validation, and we are publishing the results. But the fun part, that is what I wanted to come to as the last one here, is that, so if you notice this, very, very similar to many projects that we run, so we are reading off the S3s and, BigQueries of the world. We have got different data sources. Then we are doing some transformation on that or whatnot. Now, this particular company, what they have done is that they have built a data quality wrapper using Great Expectations on everything that they are doing. So essentially, the way they are pitching themselves is that, hey, they have got a data quality wrapper, and this data quality, and I've included the link to that as well here, and I'll show you. I found it very interesting. So they have created a data quality wrapper on Great Expectations. Now, since Great Expectations ends up spitting out all its data and all the metrics, so what you can do, think about that, is that you can run analysis further on top of that. That, okay, for my checkpoints that were running today versus yesterday versus day before versus, a month ago, how is my data changing on the basis of that? So yeah, earlier the passenger counts, they were between 0 and, or rather between 1 and 5. Now the passenger counts are turning out to be between 2 and 3. So what has changed? So that drift in data is something that they say that, our data quality product that allows you to do that. And interestingly, that is not the only thing. So they do a lot of other analysis on top of that. I'm just trying to open that, and then I'll share it here as it opens. Is that, so by the way, this is the company. And interestingly, so some of these things are, so this is the diagram that they had. But what are they doing is that they are creating suspicious volume indicator on top of that. They are creating a median absolute deviation on top of that. They are creating, all of these metrics on top of the data that GX is pumping out, which further enhances the focus on data and, how is data actually drifting and changing as we go ahead. So shift indicator and, all of these numbers, and Ram, I know that you'll be able to make more sense of these. But I found this pretty interesting that you could just end up building a product on top of that and call it our data product. That we have got a data quality product, which we have just on the basis of output that we are getting out of GX.
That's very interesting.
Yeah.
The wrapper, I mean, you mentioned the wrapper, because I was coming to that point, like this data, and if it is not correct or it is bad data, it will impact further on the quality of the subsequent processes. So it attaches some cost of quality concept to it. So building the wrapper, and if it bring out that, okay, hey, with this wrong data, what is the impact on your next operation or next transaction? Are you losing something because of that? So such wrappers will tell.
Yeah, that is one. And the next thing is that if you know that a particular pipeline like when I'm ingesting data from say Vertica, every time I've got a data quality problem over there. Like it happens twice a week at least. So we can draw those kind of analytics on top of that. That twice a week, what happens is that rest of my pipelines, they are working great, but I've got a problem with it. And then you can start narrowing down a bigger problem behind the scenes that like, is the person or the people who are dumping data into Vertica, are they doing a good job or not? So I think there are various kind of analytics that can be built on top of that once you have all of this data available to you. And like this is what these guys seem to be doing, and they seem to be doing, at least they're calling it out, like we have got a data wrapper, and we can ensure that, like whatever pipelines that we are building for you as an organization, those are going to be great because we have all of this tooling in place now.
I think other thing is, another common problem in companies, something breaks downstream, and people run all over the place trying to figure out, what went wrong.
Right.
Now, if you Git manage all of this, every time something goes wrong, you can build that back into the pipeline so that it never happens.
Yeah.
So I think you can, like over a period, achieve real good quality and downtime and production issues.
That is the key. And frankly, like this is something that we should keep talking about to all our clients. That guys, like you are talking about the AI. Let's talk about the data first. Like what is the quality of data that you have? We can do an analysis on the quality of your data and tell you how good your data is. So what we have to do is, like run this great expectation suite based on the expectations that we think we should be putting there along with the domain expertise, and just show them, yeah, guys, this is what you look as the quality of your data. And easily understandable, because like once they say, for example, we run this, like we get out a report which is very human readable, and they'll be able to see that, oh yeah, like this is what came back. And then we can show them that yeah, like if this is the kind of data that you are getting, then this is where the problem is. And like, yeah, we can change certain parameters, look at the data again, and then show them that, guys, this is where your problem with the data is, and first let us fix our data, and then we go ahead and build the models for you, because everybody is trying to build models right now, and there is, unless we have the right data, what kind of model are we talking about? And then things are going to fail. So like for one of our retail clients, Ram, as you know, for whom our friend Cognera built that system, like they said that ultimately whatever they were doing with the flip of a coin, that is better than what the model was predicting. So
yep. The good thing is,
go ahead.
No. So the part that I like is, I think it's Python code.
Yeah.
And it can be Git controlled. So I think, it's, you can operationalize it pretty well. So before this, the way I was talking to customers is DBT as a tool for data quality.
Mm-hmm.
But DBT has a limitation of only SQL-based data quality checks.
Yeah.
I think, this is definitely a plus, because now you could bring all the DBT data quality checks also into Great Expectations, and you have one single platform that is Git controlled.
Correct, and it works well with the DBT. And yeah, like, so I know that I was, so again, you could use just plain Python files, or you could use Jupyter. For me, it was just, like easier to use Jupyter. So I went there, but yeah, like nothing stops you from just going ahead and writing, like Python code, and it'll just work. So yeah. And as I was saying, like it dumps out everything. The good thing is that everything gets dumped out. Whatever expectations you are saving, whatever checkpoints that you are saving, you can load them up again if you like those, and you can run them again. So I'll try to see if I can share that part of the screen. How will we do that? So I don't know if you can see my terminal now. So
not yet.
Not yet.
Oh, not yet, is it? Maybe now.
Yep.
Okay, so so this is where that, like Jupyter Notebook is running, but we could just like I believe this is where I have the, yeah, so I could So this is where it actually pumps in all the information. You could, so all the custom data docs, we can just throw them here, like the validations, they go in here, the checkpoints, they go in here, and you can define where do you want to pump out all the data, and then we can run all the analytics on top of that. That is what, like this other company is doing. So they have all this data collated together from all the runs, and then they build further analytics on top of that.
So the checkpoints directory is the one where you see the output of the particular checkpoint, is it?
Correct. Yeah. So this is the one that will be done with the Python code. I'm running it in a different profile right now. But if you were writing Python, this is where you could do it as well.
Can you ls on checkpoints? I'm just curious what's in there.
Where am I right now? Half of the screen is actually blocked for me. Okay. So right now, this one does not have anything because I'm not running the examples from here.
I see. Okay.
They are run from. So this is where I'm running my examples from. I don't know for Jupyter whether it puts like all the information here or not, but one of the examples that I tried for on the Python code, that is where it created that structure for me.
I see. Is it?
No, the data is where I had the data for the files. Let us look at this one.
Probably in the notebook, you have to specify the output directory location somewhere.
Yeah. Right now, I was not doing any of that. So probably it is keeping all the checkpoints and everything in the memory right now. Because in the configuration, I have to provide that, okay, this is where you start go and dumping it.
Are there any, dot directories? Usually they dump.
In the checkpoint, is it?
Yeah. No, just in the grid, wherever you are running the Python notebook from.
Wherever I'm running the Python Jupyter notebook from.
Correct, yeah.
I'm running it from here. So this one maybe.
I think it's fine. Oh, yeah, okay.
Yeah.
No, these are probably, it's like.
No, but this is the simple example checkpoint that we had in the Jupyter notebook run. So
that might be the notebook's checkpoint, not Great Expectations checkpoint. It's just a copy of the notebook.
Yeah, probably you're right. Yeah, that'll be the notebooks one. Yeah.
Yeah, I think you may need some configuration to collect the output in structured format in some place, and then use that for building another layer of analytics, like the way Tiger guys are doing.
Right. Yeah, but it says that like you can dump out all the output, and like that is where it gets stored. In fact, I think, let me see. I think I did that for one of the examples. Let's go back to the notebook. And yeah, let's go to this one. So if you notice here, yeah, I don't see it right now, but I believe I did try to save it. I can try it again, and I can update the group.
Ideally, they should set it up at context level, like something like context.storage or something, some parameter.
Yeah. Because I was able to load it as well, saying that, okay, expectation.load, and then I was able to load that one as well. Let me see if I had another file for that.
Yeah, I can see, this will this will be a good data quality solution that is all encompassing and easy to operationalize, has all the tick marks required for productionizing.
Yeah, I was pretty impressed as to how many people are actually using it. And we are well, I came to know about it only once I read it on the ThoughtWorks radar. But it's used. Yeah, there are other commercial products as well. Like there was another Monte Carlo that came close to it, and they are talking about similar things. Of course, it's commercial, so they have got a little more fancy like output. But yeah, this one just integrates with a lot of things that we are using, and a lot of tool set is just covered. Like if you just want to use it.
I think it'll be cool to check if we can trigger this in Vertex AI pipelines. Like in Kubeflow, as a first step,
Yeah.
like before ingesting anything, you run this and fail right there.
And you'll be ingesting from where? From the likes of BigQuery, is it?
So ideally, it should be from a feature store. If not, if you're not using feature store, then you would be loading from BigQuery or files or whatever.
Yeah. So exactly. So one of the pipelines that I showed that did put it as per on the feature engineering part as well. So when you are ingesting, if you notice, you ingested and then as a part of the feature engineering pipeline, also you put in the validation here. So data ingestion, data cleaning, but at the time of feature engineering as well, you can put the validation and then get it to model training.
Yeah, or it could be a separate pipeline just to validate the features at an enterprise level, so that different teams using the same features would be assured that there is certain quality built into it, and they can contribute additional expectations, so on.
Yeah, that's what pretty powerful. I think we should plan to include it in our tool set.
I think it is already included.
Yeah. I think it reminds me of that guy. Okay, how do I test my data after this? And I was like, yeah, I can just write a SQL query for you to make sure that all the rows were ingested. That is actually what we ended up doing. But this one is so much more powerful than that. So we just did a count check, but that was just a layman's validation. And yeah.
Kind of interesting. This modern data stack, this diagram keeps evolving. I think, just a couple of months ago that I didn't see great expectations. Now I see reverse CTL, which is another thing that is coming up. I have to read up, but
Yeah.
I will say like we have to find out the another use cases. And I was just thinking like, say, huge data is coming at very fast speed, and this will automatically validate all that and give the feedback. So what other use cases can be built? So can this data be immediately split and push it to multiple application as required? Because application is someone will use it for analytics, someone will use for some other data building and so on. So the use case could be anything based on the data which can be added to this pipeline. That's what I was thinking. And I was again coming back to the e-commerce website applications, like data comes, but it goes only for one purpose, and then it is used by another group for another purpose. Like merchandise team used for creating the new deals or programs, whereas other inventory team is using it for something else. So can we write a pipeline next to it, which will split the data and build it and give it to someone?
Yeah, but that'll still be a pipeline. This tool is just going to be validating the data at certain points in that pipeline. So if you want to split out the data, you want to throw it onto multiple locations, that is still going to be pipeline's job and not Great Expectations job.
Okay, these will only stop at the validation.
Well, you can, as Ram says, that we can screw up the system and make it do that, but that is not what it is meant for. So ultimately, it is meant for doing that data validation. And like the pipeline tools give us enough flexibility to do the pipeline. So, Cool, guys. I think that is what I had. You all have a lovely weekend and meet soon again.
Thanks, Vikas. That
Right.
was very interesting.
Thank you.
Thank you. Have a good one. Bye.